Hi everyone, it's Rogerio. This week I wrote an article about TDD with LLMs, or how I like to call it, the complete guide for TDD with LLMs. So anyone that worked with me knows how much of a big fan of TDD. I always was the annoying guy in the teams pushing everyone else to write tests. People say that, yeah, TDD doesn't exist in practice, it's just something that you say, but nobody really does in production. And I am the living proof that yes, you actually do it, and yes, it's actually very helpful. TDD, people don't believe it, but TDD actually saves you a lot of time and makes the programming experience so much better. And yes, there are whole companies doing it every day. It's just that it requires quite a lot of discipline at the beginning, and I hate to say that. I really don't like things that like discipline, but I haven't found any other way. You need to stay in the game long enough, like for weeks or months doing TDD every day, and then you realize like, oh my god, how was I not doing it like this before? I was not writing tests before the code, and you start seeing all the advantages of it. But anyway, I've been, I think, for 7-8 years now doing TDD with a lot of my code. But then these things with LLMs came about, and I'm like, oh shit, how the hell can I test this? Because it's totally non-deterministic, right? Like you run once and then it works, then you run twice and it doesn't work anymore. I cannot write a single unit test because that's how usually you do with code. You know the logic, so you can do something that breaks 100% of the time, right? And then you implement the fix for that, and then you write the next test and you move forward. But in LLMs, it's completely probabilistic, non-deterministic. So how can I write a logical test to that? But still, I was like, but if I could, that would be so powerful, because just like we are refactoring our systems and we need to know that everything is going to work, or just like we write the test as we expect the interface to be like, the program to behave. Now I just need to do an implementation. That would be amazing with LLMs as well, because like I know what I want out of it, right? And that's how I write the prompt. But a lot of times it doesn't obey my prompt exactly, or like I had in my head, which is also hard to translate into words, right? And then you only realize later. But if I could specify a way to exactly tell what I need, then I could just keep fine-tuning my prompts until it actually works. And then, so this is basically the TDD flow, right? But then we have all these problems, which I go here on this post, and I'll go now on the video. Thinking about that, as you may or may not know, I'm co-founder of LangWatch, an LLM ops and monitoring tool. And as part of LangWatch, we created a library which we put on open source called LangEvals. This is our evaluator library. We connect various others evaluators, and then we decided to use that to write our unit tests for LLMs. So I'm going to use that today to show you how you can write your LLM evaluations as well, and like what are the challenges of doing this. So let's first start, why should you even write tests for LLM? And I think the answer, it's obviously what I said, so it makes it easier to prompt engineer and refactor, but also just because if you can find those bugs, those issues with your prompts earlier, it's actually much cheaper. So that's the same reason that we have tests for traditional software, right? Like if you have by default, your code will have bugs, like users can try all kinds of things as well. So imagine that this is the amount of all possible bugs that you have. The unit tests are your first line of defense. Maybe you have type checking, linting, and then unit tests. And then as you progress, those become more higher and higher level, like you do manual tests, and then finally monitoring until you have a customer complaining. Each of those are like a barrier of defense. So when you manual test, you can find some bugs. But the problem is it's more expensive. It takes more of your time, right? And it's more expensive in the literal sense, because if you have a customer complaining, then you're already too late in finding this bug. It may cost you direct money. So that's why we need monitoring. That's why we still need to do some manual tests. But if we can manage to do some unit tests, maybe we can spot on more bugs earlier in the game. And then the TDD process can help us go tests first. So first we think about our specification, then we write the prompts. And the amazing thing is that when you're done, you're done. When you finish the code implementation, your tests are already written. There is no extra work, just commit and push. Cool, so how can we do that? First, let's start with an example. I'm writing a recipe bot, a bot that tweets recipes. I have a little code here. It's a Python function called generate_tweet. It accepts an input and a model. We are using light LLM to allow us to switch at models anytime. So we can actually test how different models will behave with this prompt. And then here we pass the messages. We start simple enough. You are recipe tweet generator. And yeah, I put the temperature zeros just so our tests are more precise. And yeah, and I return the result. That's basically it. Very simple. So now let's start writing a test. We're going to use PyTest over here, and I already have the imports. I'm going to start with a very simple test. So remember, my prompt is simply generate your recipe tweet generator. That's it. It doesn't have any more specifications. But the thing is, I want it to be very short. I want it to fit a tweet in the old sense of the word. That's 140 characters. So let me write a test for it. First of all, yeah, write a test simple enough, test if it's a tweet, and then I call the recipe bot with generate a recipe for quick breakfast with bacon. I'm using GPT 3.5 Turbo here, and then I do a simple assertion if the length is smaller than 140 characters. Let's see, maybe it already works out of the box, right? Because I asked it to be a tweet generator. So what we can do now, let me clear this up. We can run those tests using PyTest. Let's see what happens. Apparently it didn't save the file. There you go. So my test fails because it generated a crisp bacon taco breakfast, cooked bacon, some hashtags, so it knows it's in Twitter, but it's too long of a tweet for my taste. So there you go. We did the test first. So let's now do the implementation. How can we make it generate less than 140 characters? Well, we can just ask it. Generate recipes using max of 140 characters, maybe just the ingredients, because then you can fit in less character more easily. Let's save that up and let's run the test again. Boom, the test passed. That's great, right? So now it means that all recipes that I generated will always fall on under 140 characters, right? No, of course not. Because this is you're just asking the LLM, right? You're not hard limiting it. So it might be that it goes over. How can we know if it will go over sometimes or not? And here's the thing. Here's the first problem with LLMs. One example is not enough. You need to give it more example. For something that is non-deterministic, you need to increase your probabilities. Then the best thing you can do is just test it out with your a bigger example of your problem space, right? So then you reduce the chances of finding something in the wild that is not related at all with the examples that you gave. So what we can do here is create a data set of examples. So let's give these 3 examples. So the first one that we already had, then let's ask for a recipe of lunch with lentils and then a vegetarian dessert. Okay? One thing we can do is use this PyTest annotation parameterize to give those entries as an input to this test. So what will happen here is that this test will be run once for each input, and then it will test if there is less than 140 characters for all those recipes that I'm asking. So let's see what happens here. It failed. So it failed, and you can see it failed on the second example with the lunch using lentils. But here's the thing that I want to show you. If we run this again, it actually might pass. There we go. So it passed. So just by retrying, it passed. So sometimes it actually works. And maybe that's okay. Maybe that's good enough for our needs, you know. maybe we don't need it to work 100% of the times. We just want to know that it works majority of the times, or that it works if you try enough. So one thing we can do is add this annotation flaky, because this is the big problem with unit tests and LLMs. You want your unit tests suite to be stable, so you can run on a CI, so you can run multiple times and not be thrown off by false positive. Luckily, we have this library called Flaky. You can pip install Flaky, and then you get this annotation here, which you can define how many runs you allow it to do. So then, first of all, you can see there were 3 tests passed from those 3 generations. Now we can add max run 3, so then it means that your test will be run up to 9 times. So you can, if something fails, it will just retry by itself, and there you go. The test passed now. If we run again, then it should pass again. It's now more stable. There you go. So now we have a more reliable test suite, which is still testing our examples that they work well enough, or at least 33% of times, let's say. Now we have all those examples working. What if I want to switch models around? What if instead of GPT 3.5, I want to try GPT-4 or Llama? I can just switch, right? And it will just work. No, not necessarily. We all know that the prompts are not portable. You cannot just take one prompt written for one model and move to another. It might fail because models behave differently to different prompts. So one thing we can do is also compare those models. Let's say our application has a requirement to work with different models. We can actually also add those here as a list, and then as a parameter to the model, to the test, and then we can use the model here. So what this is going to do is have a test for each input times each model. So to try the 3 of those into the 3 of those models, and then let's see the results of them. Let's see what happens. It failed there. Okay, who failed? Let's see. Okay, so Llama 3 failed. And you can see here that even though we have this retry mechanism here, right? It actually tried 3 times. It passes 0 out of 1 required, so 1 remaining out of 3, 2 remaining. So it tried 3 times and still failed. So Llama simply cannot pass. It cannot work with this. It might be time for us to refactor. We might need to change our prompt to make it stronger as a statement that, yeah, it should be under 140 character. And the simplest trick that you can do, and that's the most powerful prompt I found lately, is just this addition. No yapping. No yapping. It's a pro level prompt engineering. So take a look at this. Tell me which line to look at the bug stack trace. No yapping. The guy's telling to GPT-4, and you know that GPT-4 is very verbose, but it really works super well. Just by adding no yapping, the model goes straight to the point. And this is what we want here, right? None of the yapping, just 104 characters expressive. So okay, we refactor a prompt, we added this, now let's rerun the test. And this is the great thing about it. I don't need to test manually. I don't need to write it again. I don't need to wonder, and I don't need to feel like, yeah, I think it's good enough. You know, I actually can just rerun the test and see what happens. Cool, it passed, perfect. The power of no yapping. Even with Llama, which is the one that was failing in 2 tests in the entry 5 and 8, it now passes all of the time. And I ran this many times, and yeah, no yapping is really good. Anyway, one of the problems with this is that you're only ensuring that it runs 33% of the time, like I said, that it works, but you might want to be more strict than that. Let's say you want it to run 66% of the time to be successful. You can do that also in the retry library. What you can do is, given those 3 runs, you add at least 2 to work. So this already increases, you know, your confidence in it to 66%. So 66% of times it will work. If you want to have even less flaky, you may be put 30 out of 20, and then it still ensures the 66%, but of course your LLM cost will increase with that. But remember, it's still cheaper than having bugs in production. Yeah, so let's see that works. So now we made our tests actually more strict, and I think that's the whole point. That's all about that, you know, like this is non-deterministic. You're not ensuring that it will work 100% of the time simply because it's not possible. It's not insurable. It's a inherent non-deterministic thing. I mean, for this, you could just cut the string, something like that. But many questions for LLMs are very open, so you cannot guarantee 100%. But you can guarantee some percentage, you know, some minimum. And yeah, it works here. Although in my test it fails sometimes, so I'll just leave it more open. So you continue with that more easily. But the other problem is, oh yeah, I forgot about this. Take a look, it took 26 seconds and before 13 seconds. This is very slow. And that's the other problem with unit tests on LLMs. They are slow, they are heavy. It's not like if this was just a simple unit logical test with everything mock, this would be instant, like 0.1 second. And speed is very important when we are doing TDD, because you want to write a test and then refactor and then implement and refactor, and you want to keep on this loop. And speed is very important, because if you have to go through 30 seconds every time, you'll be very annoyed. And this is one test, right? Like if this grows, then you can be minutes here waiting. So keeping your unit tests at a very fast speed is extremely important for you to fast iterate, especially if you're writing prompts a lot, you know, like you're switching it a lot. You want to switch a bit, run, switch another bit, run. You don't want to try to change a lot and predict, you know, all at once. If you have speed, you can do small changes at a time and way more testing and get better results. So anyway, one thing you can do is use the async.io cooperative library. So the traditional async.io annotation from PyTest just allows you to run asynchronous tests, but the async.io cooperative actually runs them in parallel. And even though LLMs are heavy, those are API calls. So you can actually make those calls all at the same time. Why not? So if we change the async.io to async.io cooperative, now, boom, look at that. Maybe there's one hanging. Yeah, it took 7 seconds. I guess there was one LLM call that took longer than the others, and it was waiting just for that. But if they are all fast, then this can all end in 1 second now. So from what was it? From 26 seconds to 1 second. That's a huge difference. All right, let's move forward, because this test is cool. It already allowed us to do something, but to be honest, it's a very simple test, a very basic test. It's not the most interesting problems that LLMs can solve. It's actually the least interesting because LLMs are terrible with numbers. Usually you are doing something more open-ended, and that's the power of LLMs that you cannot do with traditional software, right? So another test that I want to write, a feature that I want to add on my LLM, on my recipe generator, is that I want all the recipes to be vegetarian. This is the kind of perfect problem for LLMs, because you cannot think of a logical system that defines that something is vegetarian or not, unless you maybe have all the lists of ingredients in the word catalog or something. But anyway, it's like, what is vegetarian, right? LLMs are very good at that. So let's write a test for it, which uses LLM as a judge. So LLM as a judge is, instead of doing an assertion like this, you can use an evaluator like any of those that we provide on the Langevals library. So if you go to our docs and you go to Langevals, you can see all the evaluators that we have here. And one of them that we're going to use now is the LLM Boolean evaluator. So you can ask anything to the LLM and it will just return you true or false. So this is perfect for writing unit tests. So I'm going to write a test that checks if the recipe is a vegetarian recipe. Let's go. So I'll also add this this flakiness test, because I know that this one will be a bit flaky, even though it's actually very reliable, this one. It almost always generates vegetarian recipes. The problem is mostly this first input, because I explicitly asked it for breakfast with bacon. So the LLM needs to be smart enough to find the replacement. Anyway, so what I do is I generate the recipe and then I add a vegetarian checker using custom LLM Boolean evaluator from the Langevals library. Then I set the prompt for this evaluator to be, look at the output recipe is the recipe vegetarian? So I'm using another LLM. I can define here if I want GPT-4 or whatever to use that. I'm using another LLM to inspect the result of the first one and just return me, this is an evaluator, and then what I can do is use the expect also from the Langevals library, that given this input and output, I expect it to pass the vegetarian checker. So the expect function will take my entries and will pass through this evaluator. So yeah, let's see, we have our tests. The first rule of TDD, you write test first, then you run it. It should be failing, because if it works already, we don't need to change our prompts, right? So let's see. By the way, it will take a bit longer for each test, even though now you see there is a bump because they're running parallel, because each test also have the LLM evaluator element in it. So, okay, it failed, and the nice thing is that it tells you exactly why did it think that it's not vegetarian, and the evaluator said that the recipe is not vegetarian since it contains bacon, which checks out. So yeah, the recipe generated was bacon, eggs, bread, and avocado, and then the evaluator said, yeah, this is not bacon. Sorry, this is not vegetarian. It contains bacon, which is correct there. The other one got retried and just worked. Cool. So how can we make this work now? Well, we can ask the LLM. So now it's time to do the implementation. Let's see. So I'm going to add this here. Also, the recipe must be vegetarian. This is the smallest addition I can make. Maybe this is enough, right? To have all recipes now be vegetarian. Let's see. We can just rerun the tests. Again, very nice that I don't need to be typing all this myself. Oh, by the way, let me just comment the other one, because then we can speed this up. Let me comment it out for meanwhile. All right, cool. All the tests passing. So asking the model to generate a vegetarian one turns out it was good enough. However, there's one last thing that I want to show you. There are some times that I think in this case, I think it was Llama that was failing multiple times. Even if we retry 3 times, I can add a mean passes here. And let's see if that happens. So I want to make it more strict, but let's see what happens here. Okay, it worked, fine. Still, I want to show you this. So what Flaky does is retrying each test. So let's say, if this input fails, it will retry 3 times. This input fails, it try 3 times. But still, it requires each of the inputs to work. And that's not necessarily what you want. If you have a large data set, maybe you're okay that not all of them will work all the time. Maybe you just want 80% of accuracy in that. So just 80% of them must work at all times. And you can define this minimum limit on your unit tests. And then if something changes, the model changes, your prompt changes, and it goes below this threshold, then then it will break. But what you can do also is increase this threshold and then make it more strict, and make sure that your prompts won't regress. But what you can do there, then this is an annotation that we provide from Langevals. You can add the pass rate annotation. So by adding pass rate, let's say 0.8, you are saying that each item will be retried 3 times. But if, or in this case, let's say 66%, but if this item fails, or in this case, this item fails in all of them, that's fine. You just need most of it to pass as a whole. And all those together, this is what gives you a lot of stability on your test suite, while still testing the minimum on how it works, and allow you to change the prompts and keep seeing how it will behave. And then if it goes lower than it already was, then you know earlier on in the game. That's it. This is what I had to show. I will share the link to this blog post in the description. please check it out. Also, if you enjoyed this, check it out, Langavals library, give us a star on GitHub. And yeah, if you are more interested in testing your LLMs and quality of your LLMs, check it out my Twitter, give me a follow over there. And yeah, see you later. Bye bye.